integral involving partial fraction decompositions. So a quick review to see what we have from last time. So there are three types that we look at for the denominator, right? Denominator is the product of distinct linear factors, denominator with repeated linear factors, and denominator when you have irreducible quadratic factor, right? So those are the three types that we mainly look at. Okay, so let's consider a few examples on the integral of this type of fractions. Okay, so let's consider the first one. So evaluate the following integral. You have the integral of x plus 4 divided by x squared plus x minus 2 dx. For this x plus 4 divided by x squared plus x minus 2, you can factor the denominator, right? You can factor that into x plus 4 divided by x plus 2 times x minus 1. Okay. So the denominator is a product of linear factors. Right? So you can rewrite this as a over x plus 2 plus b over x minus 1. Right, so this process we already done it a few times, so I'm going to speed up the process a little bit, right? So combine the two fractions on the right hand side together, and the left hand side remain the same, of course. So a times x minus 1 plus b times x plus 2 divided by x plus 2 times x minus 1. So x plus 2 times x minus 1 is the common denominator. So you match the numerator together, right? Because we have the same denominator already, so we don't care about that anymore. So x plus 4 equal to a times x minus 1 plus b times x plus 2. You remember that there are two ways to obtain a and b, right? So if x equal to 1, then you have 1 plus 4 equal to a times 1 minus 1 plus b times 1 plus 2, or this is 5 equal to 3b, or b is equal to 5 over 3. Now to get a, if x equal to negative 2, then you have negative 2 plus 4 equal to a times negative 2 minus 1 plus b times negative 2 plus 2. You have this is 2 equal to negative 3a, or a is equal to negative 2 over 3. Right, so you will be able to obtain a and b in this way. I see that when x equal to 1, this term becomes 0, right? I can obtain b automatically. When x equal to negative 2, this term becomes 0, then I can obtain a. Right. So you have a, you have b. The fractions become, well, you have x plus 4 over x plus 2 times x minus 1 equal to negative 2 over 3 divided by, what do I have here, over x plus 2 plus 5 over 3 divided by x minus 1. Or you can write this is negative 2 divided by 3 times x plus 2 plus 5 divided by 3 times x minus 1. So you have a big fraction, you decompose into smaller fractions. Now you can work with the integral, right? So the original integral becomes, right, so you have x plus 4 over x plus 2 times x minus 1 dx is equal to the integral of negative 2 over 3 times x plus 2 plus 5 over 3 times x minus 1 dx. And you know that the integral of the sum is the sum of the integral. So this is equal to the integral of negative 2 over 3 times x plus 2 dx plus the integral of 5 over 3 times x minus 1 dx. So negative 2/3 is the common multiple. You can write this as negative 2 over 3 times the integral of 1 over x plus 2 dx plus 5 over 3 times the integral of 1 over x minus 1 dx. So the integral of 1 over x plus 2, right, gonna give you negative 2/3 times ln of absolute value of x plus 2 plus 5 over 3 times ln of absolute value of x minus 1. And you could ask that where all of this ln of, okay, plus c, right, where all the ln coming from, right? So last week we actually looked at this type of integral and we showed that you can obtain the integral in this form using substitutions, okay? Let me do this one more time, but moving forward, you can automatically apply the formula that you have 1 over a linear term, in turn the integral of 1 over a linear term equal to ln of absolute value of the denominator most of the time. But so let's evaluate this integral 1 over x plus 2 dx. Well, like I say, if you use substitution, hopefully at this point you feel comfortable with this type of problem, right? So you let u equal to x plus 2, then du equal to dx, right? Therefore, the integral is 1 over u du. Or this is equal to ln of absolute value of u plus a constant c. You start with x, you should end the problem with x, right? So this is equal to ln of absolute value of x plus 2 plus a constant c. And using the similar manner, you could be able to obtain that the entire derivative of 1 over x minus 1 is equal to ln of x minus 1. So this is the formula I'm talking about, right? So in general, if you have in general 1 over x plus a dx, this is equal to ln of absolute value of x plus a plus a constant c. You have the integral of 1 over x minus a dx is equal to ln of absolute value of x minus a plus a constant c. And the integral of 1 over a minus x dx equal to ln of negative ln of absolute value of a minus x plus a constant c. For this integral, the answer is negative ln of x minus a, absolute value of x minus a. And if you use, like I say, if you use substitutions, you will see why this is positive in this case, and why is this negative in this case. Example, next example. Evaluate the integral of 4x divided by x minus 1 squared times x plus 1 dx. Alright, so when you look at this integrand, you have 4x over x minus 1 squared times x plus 1. So 1 is the repeated linear factor. 1 is just a linear factor. Consider 4x over x minus 1 squared times x plus 1. Right, so x minus 1 is the repeated linear factor, and x plus 1 is just a linear factor. So you decompose them as follows. A over x minus 1 plus b over x minus 1 squared plus c over x plus 1. And you combine the three fractions on the right together. You have a times x minus 1, x plus 1, plus b times x plus 1, plus c times x minus 1 squared. All together divided by x minus 1 squared times x plus 1. And the left hand side remains the same. So now the denominator is the same already. You just match the numerator together. So a times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 squared. So you have 4x equal to a times x squared minus 1 plus b times x plus 1 plus c times x squared minus 2x plus 1. Now you distribute and combine like terms. F 4x equal to ax squared minus a plus bx plus b plus cx squared minus 2cx plus c. Alright, so combine like terms. You have a plus c times x squared plus b minus 2c times x minus a plus b plus c. So now you match the coefficients on both sides of the equations. So we have a plus c equal to 0, b minus 2c equal to 4. And the last one is negative a plus b plus c equal to 0. So you have a system of 3 equations with 3 unknowns. Alright, so let's solve for a, b, and c. Right. So let me solve for a here in terms of c. And also in the second equation, let me solve for b in terms of c. From here, I can substitute a and b into the last equation. So substitute a equal to negative c and b equal to 4 plus 2c into the last equations minus a plus b plus c equal to 0. I got negative c plus 4 plus 2c plus c equal to 0. So this is c plus 4 plus 2c plus c equal to 0. Or in general, you have 4c equal to negative 4, or c is equal to negative 1. Since c equal to negative 1, you have a equal to negative of negative 1 equal to 1. And b equal to 4 plus 2 times negative 1 is equal to 2. So the integral becomes so you have the integral of 4x over x minus 1 squared times x plus 1 dx. This is equal to the integral of 1 over x minus 1 plus 2 times x minus 1 squared minus 1 over x plus 1 dx. So you can separate this into 3 different integral. 1 over x minus 1 dx plus 2 times 1 over x minus 1 square dx minus the integral of x plus 1 dx. So for the first integral, you have ln of absolute value of x minus 1. The last integral is ln of absolute value of x plus 1. Don't forget to put the plus constancy at the end. What about the middle integral? So to evaluate the middle integral, you use substitutions again. So one more time, substitutions, let u equal to x minus 1. Then you have du equal to dx. Now the integral becomes 1 over u squared du. Or this is integral of u to the negative 2 du. Or this is u to negative 2 plus 1 divided by negative 2 plus 1 plus a constant c. Or you have negative 1 over u plus a constant c. Or this is 1 over x minus 1 plus a constant c. So go back to the second or the middle integral. This give you plus 2 times negative 1 over x minus 1. Let's move on to another example. So evaluate the integral of 2x squared plus 1 divided by x times x squared plus 9 dx. We look at this, you see that in the denominator, you have one is the linear factor, the other one is the quadratic, irreducible quadratic factor. So consider 2x squared plus 1 divided by x times x squared plus 9 is equal to a over x plus bx plus c over x squared plus 9. So once again, combine the two fractions on the right hand side together. You have a times x squared plus 9 plus bx plus c times x, all together divided by x times x squared plus 9. And the left hand side remains the same. You have the same denominator, so match the numerator together. You have 2x squared plus 1 equal to a times x squared plus 9 plus bx plus c times x. Right. So distribute distribute and then combine like terms. Right. You have ax squared plus 9a plus b x squared plus cx. Combine like term, you have a plus b times x squared plus cx plus 9a. Right. So match the coefficients on both sides of the equations. Right. So we have a plus b equal to 2, c is equal to 0, and 9a is equal to 1. So you know that c is equal to 0. From here we can obtain that a is equal to 1 over 9. So I have a equal to 1 over 9. C is equal to 0. So what is b equal to? 17 over 9. So the integral becomes, you have the integral of 2x squared plus 1 divided by x times x squared plus 9 dx. This is equal to the integral of 1 over 9 divided by x plus 17 over 9x. Let me be careful here. So 17 over 9x divided by x squared plus 9 dx. Alright, so this give me the integral of, so 1 over 9 times the integral of 1 over x dx plus 17 over 9 times the integral of x over x squared plus 9 dx. Right, so first integral is very straightforward. Right, you can just easily obtain that. 1 over 9 times ln of absolute value of x. But for the second integral, you have to use substitution method to evaluate. Right, so 17 over 9 times the integral of x over x squared plus 9 dx. Right, so substitutions, right, you let u equal to x squared plus 9, or du equal to 2x dx, or 1/2 du equal to x dx. So you have 1 over 9 ln of absolute value of x plus 17 over 9 times 1 over u times 1/2 du. Or this is 1 over 9 times ln of absolute value of x plus 17 over 9 times 1/2 times ln of absolute value of u plus a constant c. Well, this is 1 over 9 times ln of absolute value of x plus 17 over 18 times absolute value of x squared plus 1. Sorry, x squared plus 9 plus a constant c. So, example, evaluate the integral of x squared plus 2 over x plus 2 times x squared plus 1 dx. Right, so consider this x squared plus 2 over x plus 2 times x squared plus 1. Right? So one is a linear factor, the other one is irreducible quadratic factor. Have a over x plus 2 plus bx plus c over x squared plus 1. Combine the two fractions on the right together and then match the numerator together. You get x squared plus 2 equal to a times x squared plus 1 plus bx plus c times x plus 2. Then on the right hand side, you distribute and combine like terms. You have ax squared plus a plus bx squared plus 2bx plus cx plus 2c. Or this is a plus b times x squared plus 2b plus c times x plus a plus 2c. And on the left is x squared plus 2. Right. Now you match the coefficients on both sides of the equations. Right. I'm going to skip the formality and just write a plus b equal to 1, 2b plus c equal to 0, and a plus 2c equal to 2. From here, you can solve for a, which is 1 minus equal to 1 minus b, and then you can c is equal to negative 2b. So the last equation is 1 minus b plus 2 times negative 2b equal to 2. So you have from the last equations is negative 5b equal to 1. So b is equal to negative 1 over 5. Right. When b is equal to negative 1 over 5, you have 1 minus negative 1 over 5, which is 1 plus 1 over 5 is 6 over 5. And c is therefore equal to 2 times negative 2 times negative 1 over 5, or 2 over 5. So the integral becomes x squared plus 2 over x plus 2 times x squared plus 1 dx. 1. So you have this integral of 6 over 5 divided by x plus 2 dx plus the integral of negative 1 over 5x plus 2 over 5 divided by x squared plus 1 dx. So this gives me 6 over 5 times 1 over x plus 2 dx minus 1 over 5 times x over x squared plus 1 dx plus 2 over 5 times 1 over x squared plus 1 dx. So I move a little bit fast, but most of the technicality you already know. Right. So now you have 3 integrals. This integral is equal to 6 over 5 times ln of absolute value of x plus 2. The last integral is 2 over 5 times arctangent of x. Right. So this integral can be done by u substitutions. So this, let me do the middle integral here. You have x over x squared plus 1 dx. Right. So once again, this is u substitution. Let u equal to x squared plus 1. Therefore, du is equal to 2x dx. This is 1/2 du equal to x dx. The integral becomes 1 over u times 1/2 du. This is 1/2 times the integral of 1 over u du. This is 1/2 times ln of absolute value of x squared plus 1 plus constant c. So you bring this into the problem, you have this is negative 1 over 5 times 1/2 times the absolute value of x squared plus 1. Don't forget to add plus constant c at the end.